I went to MIT and caught up with students and others on campus, putting them on the spot with physics questions. No preparation, just quick thinking. Check it out and see how they did. This playlist features videos where I visit Boston area colleges and ask students conceptual physics questions. It's meant to be both entertaining and educational, giving viewers a fun way to explore physics concepts through real student interactions. If you have any great conceptual questions for me to ask on my next trip to Harvard, MIT, or other Boston universities, drop them in the comments section below. And here's the question. When you put salt on ice, it lowers the freezing temperature. Do you know why this happens? What is the science behind it? I'll provide the answer shortly, but let's see how the students do when they're put on the spot with no preparation.
Hello, I'm Jeff Zhu.
And well, are you guys students here?
Oh yeah, I'm a incoming freshman here.
Incoming freshman, awesome.
Yeah, my name is Eduardo Hernandez. I'm also incoming freshman.
Okay.
My name is Sergio Long, and I'm also an incoming freshman.
All right, fantastic.
Salt on ice.
Is it because it's...
Heavier?
No, it's not a bad answer, but no, it's not because it's heavier.
It has something to do with the ions, right? Like,
Yes.
it messes
the answer
up.
is yes, it has something to do with that. Yes.
Okay.
Oh, what'd you say?
I've tried to draw on my chemistry knowledge, but
Okay, I mean, if we don't know, it's no big deal. It's not the end of it.
I think.
Does it make it like, okay, so I know that it forms like the different kind of structure, because water structure is like unique.
Yes.
The water structure is unique. That maybe it makes it easier
The
to...
ice structure. What do you mean the water structure? Do you mean
The ice structure, yeah.
Yes.
When they freeze, they connect in a unique way. Would it make it more, I would say, ionic?
The salt like tampers with the crystalline structure of the ice.
So yes, you both combine together to create.
Yeah,
Yes, there's a certain crystal structure that ice has, and when salt comes in, it breaks up, and because it's a polar atom, it changes the crystal structure. What's your name?
Ethan.
And are you a student or a postdoc?
I'm a postdoc, yeah.
Okay, what do you study?
I'm in electrical engineering.
Electrical engineering, cool. Okay, where did you go to college?
Undergrad at Cornell.
AcePhysics.org, math and physics tutoring with Dr. Hudis. If you put salt on ice, it lowers the freezing temperature. Do you know why? Do you know why that happens?
Actually, not off the top of my head. I think it's because it's like it absorbs in and then it makes this it dissolves into the water, and then you have all these like defect sites from where the salt is like inside of the water, which like makes it so it can't crystallize as easily.
Yes. What's your name?
Aram.
And are you a postdoc or graduate
I'm
student?
a professor.
Oh, you're a professor.
I am,
Wow.
Yeah.
Awesome. That's really great.
Yeah.
Okay. What area do you study in physics?
I do quantum computing. Good question. I don't want to say in a video why it happens because I'd have to look it up to make sure I wasn't getting it wrong.
Okay.
My name is Anya, and I'm a rising junior
And what do you study?
at school.
Yeah.
I'm a high school student. We don't really have like
Oh, you're
majors.
a high school student. Okay.
Does-
You look older than that.
Oh,
Okay. All right. So, have you taken AP Physics?
yes, I've taken AP Physics 1 and 2, and also Mechanics C.
Okay, this is great.
So,
You're
ice
not-
freezes.
Yeah.
Ice freezes by the formation of ice crystals in the water. So when you have like salt molecules, it messes up that structure and makes it a little more difficult for the crystals to form.
All right, that's absolutely right. Getting pretty impressed with you. Ice is a fascinating substance that can exist in many different crystal forms depending on the temperature and pressure conditions. Ice is made out of water, and water is H2O. It has 1 oxygen and 2 hydrogens. Water is a polar molecule, which means part of it is more negative and part of it is more positive. When the water freezes, it forms crystal structures. This is an example of that. The negative oxygen of one water molecule will want to be closer to the positive hydrogens of another water molecule when they're frozen in close proximity together. This is a picture of ice crystals. As you can see, they clearly form some crystalline structure. There's some pattern there. And the ice crystals are very beautiful, by the way. This is an electron microscope picture of a hexagonal structure of ice. Table salt is also known as sodium chloride. Table salt, like most things, forms a crystal structure, and table salt is weakly bound together with ionic bonds. For table salt, it works out that the chloride ion becomes negative and the sodium ion becomes positive, and then they form this structure based on these ionic bonds. When the table salt dissolves in water into chloride ions and sodium ions, the negative chloride ions will want to be closer to the positive hydrogen atoms in the water molecule. And that's what you can see from this picture. Similarly, the positive sodium ions will want to be closer to the more negative oxygen atom in the water molecule. And that's what you can see in this picture. When you add salt to water, it disrupts the orderly arrangement of water molecules that form ice. Pure water freezes at 0 Celsius, which is also 32 Fahrenheit. When salt is added, it interferes with the formation of the ice structure, meaning that the water needs to be at a lower temperature to freeze. Salt, which is also sodium chloride, dissolves in water and dissociates into sodium plus and chloride negative ions. These ions get in the way of the water molecules trying to form ice. The presence of these ions means that fewer water molecules are available to freeze into ice, thereby lowering the freezing point.